Hello, here is Michael Pulin. I continue presentation of pattern distributed transactions for microservices. It's part 2, compensating transaction. The problems of distributed transactions in the microservice-based implementation are well known in the industry. We described them in the first part of the pattern called business case and presented earlier. Also, you can read about them in publications such as Patterns for Distributed Transactions within a Microservice Architecture and Compensating Transaction Pattern. The Red Hat's publication recommends using the Saga pattern for distributed transactions, though they recognize that it also introduces a new set of problems such as how to automatically update the database and emit the event. We think that there are much more problems in Saga pattern than just quoted, but today we will talk about compensating transaction. Compensating transaction is supposed to be used for compensating real-world effects caused by the steps of original transaction if one of them fails and the transaction is needed to be rolled back. Actually, it is a much more complex task than just to roll back trivial database CRUD operations, like creating a new record in the locked database table and then deleting it. It is an inappropriate example, by the way, because the goal of compensating transaction is to compensate the effect of the action, not undo it. Imagine that the database table has not been locked and someone was able to update just created record. What will you delete in this case? Or if another microservice obtains the just persisted data before the data has to be deleted and starts its own processing. So the deletion does not compensate the initial action. In SOA, it is known that the behavior of the service depends on its execution context. If you do not know this before, please try to remember. The same service changes behavior depending on the technical and business context it is used in. This is a new quality and aspect for the service development comparing to the familiar object-oriented development. So, when a transaction takes place within an application or across application boundaries, it's two different cases. If it is within an application, the compensation can appear as a simple undo. When the work takes place across applications and for example, you need to persist data and send a notification email about it or fire an event, you have to do more things than just simple undo. The compensation cannot be completed because you cannot undo the email sending. It's gone. If the database operations fails, you have to send another email asking whatever receiver to perform all needed activities to compensate the consequences of the previous email. If you control this receiver, you can follow and enforce compensation logic. But what would happen if you do not control it? What if the receiver does your sender does not know, and the receiver might not care about your transaction and will ignore your second email, or the receiver's compensation may be inadequate to your action. How do you know that your failed transaction is compensated at all? Note, I'm talking here about an environment of an individual microservice. That means I'm talking about above and across several of microservices. If you cannot see this picture in this way, you have an option here to advance your design skills, because without such view, overall view, you cannot make proper design of individual microservice. Let's look at the example. This is quite realistic example in which customer places a retail order with a seller company and pays for it via a website. The microservice 1 and 2 receive the request and persist them. And when it's done, through the events, they notify microservice 3 to fulfill the request. Microservice 3 performs this activity and delegates the control to the microservice 4 after it created the order. Microservice 4 engages vendor, actually outsourcing vendor, and sends the request for performing work for the order. At the same time, microservice 3 is supposed to manage the payment processing, but at the end of the payment, which was initially confirmed, the payment couldn't go through because of lack of funds. So microservice 3 recognizes this situation and has to issue a cancel for the order. Before microservice sends the compensating instruction to the outsourcing company, they have charged the seller already for their service. So the order is in production and delivery already, as you see on the right hand side of the picture, while the compensation is still in the debates in the processing. This is the exact situation we get into with microservices in the distributed transactions, where independent microservices are deployed on the distributed clusters with resilient event buses, messaging, and networks of API endpoints. This causes poorly predictable latency in the communication. As a result, the effects caused by completed actions of failed distributed transactions can be quite long and far-lasting. Data can be overwritten and acquired and propagated in barely understood invocation chains through the microservices, especially if it happens across the application boundaries. The saga pattern is designed in the assumption that the compensating transaction is always available. Therefore, Saga states that each individual step of the distributed transaction can be completed in full isolation from the status of other steps by using local transactions. As we see, in reality, this assumption states false. Well, it may work for some very small cases, not in the general cases. The saga pattern does not save business from the transactional failure. I can enumerate several cases where compensating transaction does not work in the distributed environment. I eliminated only 5 of them, while there may be much more. First of all, the data might be overwritten by another request through the same microservice as I mentioned already. Another example, microservice can obtain initial data before the data has to be compensated and start its own chain of processing, which is quite difficult to follow. Another microservice can fail to follow the compensating instructions because it's developed independently from the one which managed the transaction, and it might have different understanding of what does mean compensation. Communication about compensating can fail. That means the network can fail, firewall can fail, or whatever, but the command about compensating did not go through. And finally, some transactions actions and effects they cause may be not compensable. That's the case with sent email or firing event. You cannot take it back. My overall conclusion is that impacts of many transactional actions in the distributed environment cannot be compensated, either due to the prohibiting complexity and cost or due to unforeseen business consequences. The latter means that some microservices might be designed and deployed and developed without considering compensating activities for certain contexts. To minimize the effects of failed distributed transaction, I propose a conditional rollback process, or CRBP. It does not carry a notion of compensation. It just tries to undo the changes caused by completed steps where no risks of uncontrollable consequences exist. That means undo not all steps but only special one. This process still can improve the overall outcome of the failed transaction. It goes without saying that each step of distributed transaction and its possible conditional rollback should be documented with the risks of failure. And overall conclusion: failing microservices in the distributed transactions should be mitigated at runtime where possible, for example using SIB and tandem pattern. The conditional rollback and mitigation are the prerogative of the transaction orchestrator or transaction manager, which we will be discussing in the next presentation. Thank you very much for your time.